Greeting, ladies and gentlemen. Today video we're going to answering the 9th question. The 8th question. The design specification of a 1.2 meter long solid transmission shaft require that the angle of twist of the shaft not exceed 4 degrees. When a torque of say 750 Nm is applied, determine the required diameter of the shaft, knowing that the shaft is made of the steel with an allowable shearing stress of 90 megapascal and a modulus of rigidity of 77.2 gigapascal. So essentially there is the questionnaire asking us to design a shaft, design the diameter for the shaft. The shaft have a specification about 1.2 meter long, and the angle of twist, this must not exceed 4 degrees, and the torque what apply is 750 Nm. The material of it will be steel, allowable shearing stress, since it is steel, it have an allowable shearing stress which 19 megapascal and modulus of rigidity 77.2 gigapascal. So in this question, I make two way of problem solving, but two of it I get a different answer. So I'm very in the end of this video, I'm very asking your help if you do have a reason why I have been contemplating about this problem until now. It's like a 6 month, and yet I don't know why I'm using the first method and the second method and get a different direction in the different value. So I hope if you were watching my video and you know why, maybe I'm do wrong, you do tell me. Maybe there is the miscalculation, do tell me, because I'm very hope that someone can explain to me why I'm using two different methods. I'm thinking that I had made the correct principle by using those two formula, but yet I'm get different answer. But anyway, for the first one, I'm using this equation. But since that the second equation I'm using, it is get to the answer, so I'm just gonna go through to the first problem solving. To the second problem solving, I am using the shearing strain formula, the relationship between shearing strain and the angle of twist, C over by L. C times by the phi over by L. C is the radius for the shaft, phi is the angle of twist, L is the length, just 1.2 meter long. So we'll have a value of length, we'll have the value of phi, which is 4 degree. In this equation, we were using angle in the form of rate. So you get the 4 degree, you need to convert it into rate. You times it by pi, or you over it by 180 degree. So you will get 0.0698 rate. So there you kind of have it, the value of phi 0.0698. Now you don't know what is the value of C. You don't know what is the value of shearing strain. We have another equation for the relationship between shearing strain and shear stress over by modulus of rigidity. You know what is the tau maximum. There will be shear stress maximum, that would be the allowable shearing stress 90 megapascal. You know what is the modulus of rigidity, which is the, where is it, 77.2 gigapascal in there. So you calculate it, you will get shear strain 1.1658 times by 10 to the power of -3. So you bring back the core equation, then you transfer the value to the other side, then you will get 14 millimeter. Or I make a tree method. There is the first one, there is the second, and there is the third one. Then I'm getting 3 exact different value. But anyway, let's go through. So for the second equation, I'm getting 40 millimeter from the combination of formula shear strain equal to C phi over by L and shear strain equal to tau maximum over by modulus of rigidity. For the third equation, I am using angle of twist equal to tau prime times by L the power of G. I don't know what is the what we call the formula it is, because I'm quoting it from my notebook. So there you kind of have it. You will have internal torque 750 Nm. You will have a length 1.2 meter. You don't know what is the value of J that refer to modulus of rigidity. You know what is the modulus of rigidity, the J that will be polar moment of inertia. You don't know what is the value for polar moment of inertia because it consists C, which is radius, which is the question that we were dealing with. You know what is the modulus of rigidity, 77.2 megapascal. The phi, the angle of is 0.0698 in the form of rate. So you insert all of the data into the equation. So you leave out the value of J alone. For the value of J, since that we were dealing with the with the solid shaft, solid transmission shaft, so the polar moment of inertia, that will be pi over by 2 C the power of 4. So since that you know what is the J were equal to, so you will get the value of C right there. Since that the question asking the diameter for the shaft, you times it by 2, you will get 36.1 millimeter. So this is the answer by using the third equation, by using phi equal to tau prime L over by JG. For the first problem solving of mine, I am using this equation, tau maximum equal to tau prime over by the value of polar moment of inertia, which is J. By this the after I make it after I simplify the equation, because the core equation will be tau maximum equal to T prime C over by J, the polar moment of inertia. Since that the polar moment of inertia for the solid shaft, there will be where is it, pi over by 2 C the power of 4. You can cancel out the value of C in the upper side with this C, so you will lift up this equation with this one, which is T prime internal torque over by pi over by 2 C the power of 3. So there you kind of have it right there. Oh, sorry. So you don't know what is the tau maximum. You know what is the tau maximum, that will be 90 megapascal. Sharing the maximum stress, the allowable stress, that will be 90 megapascal. The value of internal torque, there will be 750 Newton, which equal to the applied torque. Internal torque is equal to applied torque, but in a different direction. So you will get the value of J in there, because I'm pronoun this thing, I'm not directly find out the value of C, because there is a lot of number right there. So I'm just remaining in the value of J. So the value of J, there will be 1 over by 1 to O. So then I'm convert the value of J into pi over by 2 C the power of 3. So you transfer the value to the other side, you will get 0.017 meter. You times it by 2 because the question asking the diameter, you will get 34.88 millimeter. So I am using 3 different equation. It will bring 3 different value, which is for the first equation I am using tau maximum equal to T prime times by C over by polar moment of inertia. Then I will get 34.88 millimeter. Second equation, I'm using shearing strain formula. Shearing strain equal to C times by pi over by L. Then you will get 14 millimeter. The third one that bring to our schema answer, which is 36.1 millimeter. I am using the angle of twist equal to tau prime times by L over by J, polar moment of inertia for the solid shaft, times it by modulus of rigidity. So if you do have an answer why I am using 3 different formula, I am 100%, if my Lord will, very confident with the principle that I'm using in use this equation, but I get the wrong, not the wrong, but the different value for the 3 of it. So if you do have an, for the first one, there will be advice. The second one, there will be, you know why I get different answer. Do tell me in the comment section. Thank you for watching and have a nice day. Bye bye.